only one question application, 7.2.
All right, guys, so I got a question, 7.2.
Yeah, I think so.
Oh, all right, well, 73, 74, they're like the same thing. 74 is kind of silly. So let's look at 73. So this one gives you this formula here.
Ramification means.
All right, I like it. So, 73 in 7.2.
Okay.
So this is interesting because it's almost right. This is a formula that calculates your stopping distance. And this thing called the coefficient of friction, it's a measure of how much friction there is. Obviously, when it rains, that number goes down. It's not as high of a friction. Mm-hmm. And the different types of roads have different types. But how much do we have to know about that? Nothing really. Part A just says multiply these and simplify. So how would I simplify that? That's the only thing I can really do.
Just divide 30.
Yes.
Yeah, like you can kill a 0,
30.
and then 3 goes into 90 30 times. So how could I rewrite this? It would be
30 over X.
30 over X. And X, in this case, is your coefficient, is that friction measure, the measure of how much friction there is. So it's the stopping distance if you're going 30 miles an hour. And part B just says, what if it's icy road is 0.1 and a dry pavement is 0.4, like I was saying. The slippier, I like that word. Slipperier, is that a word? The more slippery that a road is, the smaller X is going to be. And now stay with it. All you got to do for part B, is plug the X's they give you in. Don't make too much out of it. Now, let me talk a little bit about the physics of this. If I make X small, and when it gets more slippery, X gets smaller. So if I divide something by a smaller number, my answer gets bigger. I like it. So when X gets smaller, my stopping distance increases. It makes sense. When it's really icy, you don't want to try to stop. You go, holy crap, you're going to... No good. You want to give yourself a little more distance so you can actually stop. All right, I like it. Maybe. So that's the point of the problem.
Okay.
I like it.
It's the same 40.
74 is the same kind of problem. Same kind of problem. Yeah. Except that nothing even reduces on, well, just one thing reduces on 74. Anything else left over from homework stuff? Do my homework for me, Jeff? No? Well, you'll do really good, Jeff. No, I won't. I'll purposefully get it all wrong. All right. So we left off. Let me give you guys 2 to try to get back into where we were. You guys try these 2. What's 2, Jeff? I don't know, man. I forgot. Okay, let's do that one. I like it. Do those. Just in case you were one of the few people that missed yesterday's class. If you were here, help them out. What's the first thing you should do?
Common denominator.
Good, but what's the first thing you have to do before you can even start to think about that?
Put a plus and change the sign.
Sure, you got to do that. That's the very first thing you should do.
Exponent.
Factor at the bottom, so you see what they got. I didn't hear them. Sorry. All right. You're good. You're fine. You got it right. I just missed you. You wanna- Feels good to be full time. No, I'm not teaching. I'm not teaching 110 or whatever. No, I keep forgetting. Somebody's supposed to remind me to bring the schedule. So we can talk about. When's registration? When do you guys start to register?
Already did.
I did already.
No. For fall.
Oh, they won't send it out till the.
I mean, the summer, there's not that many choices. So if you have questions about who to take in the summer, I'm teaching 110. I can't remember who's teaching 103. But if you're registering for summer, you can ask me. But I want to bring the fall schedule and talk about, look at who you could maybe take off the record.
Wait, is like signing up for summer classes, is that just like doing it regularly? Wait, is it like...
The process is the same. Yeah.
Wait, it's just like, I could like sign up today?
Yeah.
It sounds like some people have started to register.
Yeah.
Exactly. It's the same kind of priority registration. Certain groups, but the state allows them to go first,
Okay.
and then yeah.
But why you change your time? It was the time was finishing 2:05. Now it's 2:15. I'm done.
Your registration time?
No, the time of the
finishing
class,
The time of the
yes.
class.
I don't know.
Oh, I finished at 2:05.
I didn't really.
It's 10.
I didn't
It's
pay
10
attention.
minutes, but I told them I would leave at 1:40.
Oh,
because
okay.
the schedule.
Because he just managed it because of his work.
I got you. When did they change that? I didn't even
A
notice.
couple days ago.
Really?
Yes.
I didn't even notice.
It was 2:05, now it's 2:15.
I'm gonna still let you out too. All right. You guys.
So after we factor the denominators,
Yeah, let me catch up to you guys. How do you factor this?
X. X minus blah, blah.
Plot. What's that?
X.
X,
X plus.
All right. So now you step back, and the whole idea of LCD is to make the bottoms the same. So whatever's there, you want to give them something additional so that they each become the same thing. So the idea is almost too simple to believe. They both have what?
they both have X times.
They both have X. This one has X minus 3.
No one has
This one has X plus 3. So what does he need?
X plus 3.
X plus 3, because he's got it. I always think maybe like two little kids. Thank God I don't have kids, because he's got more ice cream right here. He's got more ice cream. I'm going to eat the ice cream. My kid charges against me or something. So this guy needs an X plus 3 to make him happy. And now he's still not happy, of course, because what does he need?
X minus
X
3.
minus.
X minus 3. And now I force the bottoms, they're the same. Their bowls of ice cream are exactly the same. I've weighed them, I've measured the height, I put the same number of sprinkles, counted them each one by one. If you have kids, I'm sure remember that's how I was.
Yes.
Mary, my sister's got more than me. Nobody gets in the ice cream. Oh, shit. All right, so now, Nathan, you had a good suggestion earlier. There was that minus sign. Always pay attention when that's a minus sign. And Nathan said a good idea. Just make that plus and negative. I agree. So then when you get
Now,
it,
let me change the sign of the numerator's coefficient.
yeah, the negative can either go up top or down below. And we almost never put it
But
down
you
below.
don't transfer it to the X minus 3.
Oh, now I am. By distribution, yeah.
But you don't, when changing the sign, you only change the sign of the original number up there?
So if I have this sitting here, right? Is that 1? Do I even need that there?
No.
No. So if I take it away, I haven't really changed anything, right? Isn't this the opposite of what it was?
Let's say it was a 5.
Okay. So there's a 5 there. So that whatever this is 5 times this 5. Now if I make it negative 5, now it's going to be the opposite signs of what it would have been. The negative does go through, I just didn't do it first. Now I'm going to distribute the negative. So what do you get? I mean, now I'm going to distribute the negative to both of these.
Wouldn't you first when you change the sign, change all the signs of the top and then?
And then what?
Because when you're changing the signs, you're only changing the signs of the one. You're not changing the sign of the X or the negative.
But I need you to see how those are the same thing. If I change, right now, if I bring a 1 through, what do I get?
Exactly the
I
same.
get X minus 3. If I bring a negative 1 through, what am I going to get? Negative X plus 3. So I am changing both signs. I just haven't brought the negative through yet. That's the very next thing I'm going to do.
So it's actually, you can do it in either way.
Yes, because they both end up in the same place.
Exactly.
I like it. Cool. So what do I get here?
2x plus 6.
And then here?
Minus x plus 3.
And it's going to be all over what?
X.
X.
X minus 3, x plus 3.
Now don't write this again here. We know we don't do that, right? 4/5 minus 2/5 is 2 over 5, not 2 over 10 or something weird.
Yeah,
Right?
like-
If they're the same denominator, they stay that denominator. But when the variables come in, we start to think everything's changed. No, nothing can change. Nothing's changed. And now, what's the next thing I do?
That's
Yeah, what do I get here? I get
Like terms?
Yeah, X
X
plus 9.
plus 9 over X, X minus 3, X plus 3. So does anything cancel? Can I kill these X's?
Yeah.
No.
No, good. Because the top has what?
Oh, it's
What's the top half?
one term.
X plus 9.
Addition.
Yeah, exactly. Well, the top has an X plus 9. Does the bottom have an X plus 9?
No.
No, so I can't do shit.
X.
I can't do anything. There's nothing common to both, so I can't go any further. Don't multiply the bottom out. It's just a waste of time. I mean, it's the same thing if you multiply it out. Yeah.
If you ended up with x squared plus 9 at the top, would you have to do the difference of squares?
It would be a sum of squares then, but if it was X squared minus 9, yes, then
And then you can cancel out the bottom?
whatever you can do at the end that goes towards reducing it, which is factoring in and seeing what's common, that's what you got to do. That's the very last thing you do.
And it would be okay to cancel the top stuff with the bottom stuff and just end up with x?
Of course.
Okay.
Totally. So if this would have been an X squared minus 9, it would have factored to be these. All that stuff would have canceled. I would have had 1 over X.
Okay.
Cool.
If we ever want to turn off that in the numerator, you have the same thing in the denominator, but you can cancel out first.
Okay. I think I know what you mean, and there's an example I wanted to do next after this.
Like terms. 6 times.
Has anybody tried this one out yet?
Me, yes.
All right, do that. Don't freak out that there's 3 terms. Who cares? Process doesn't change.
Here's positive, here's negative.
Just have 3 kids now instead of 2. They all want their ice cream. Do you see how?
Something?
You see that 1 over X? On the next step, you change the bottom, but you didn't change the top.
Oh.
There you go. Whatever you do to the bottom, you got to do to the top. This is really not that at all. What's the only thing I can factor up
The
there?
middle one.
The middle
X,
one.
yeah.
What do you got?
X.
X minus 2.
X negative 2.
So what's he missing?
X minus 3.
Yeah, these guys have an X minus 2. It's not fair. And what's he missing?
X.
X
X. These guys have an X. It's not fair. Let me stop there for a second. What's up?
We're getting. Yeah.
Does the 2 need anything? The 2 has an x already. The 2 has an x minus 2
You
already.
don't have to add it just because it already had it in the denominator.
Exactly. I mean, if I had 1/3 plus 1/9, what's this guy need?
3.
A 9.
9.
He needs to have a 9 at the end, so I need to give him another 3, right? Do I give him anything?
No.
He's already got 3 and 3. So I don't give the thing that's already got stuff. I don't give him anything.
Okay.
To make this into an economic policy, but we won't. So you only give the things that are missing something, and then that forces the bottoms to be the same. If you give everybody what they're missing, now everybody has the same thing, right? So it's it sounds like communism. No, it's just algebra. Leave it alone.
No.
So we got what do we
X
get?
minus 2
X minus 2
plus 2,
plus 2.
2 plus 5x.
Yeah, plus 5x. So the tops, now that I've got all the bottoms the same, I'm allowed to just add the tops together. All over.
X, y, x minus 2.
I'm stopping.
Add the tops.
Is that cool? So I took that top, plus that top, plus that top, all over the common bottom. Bless you. Because that's how fractions work. Once you have the bottoms the same, you just put the tops together. That's how fractions work. I don't care if there's variables in there or not. They're still fractions. So what happens on the top?
6x.
Yeah, these 2's go away.
Yeah. Over x, x, y minus 2. That's it.
Yeah, now,
Now you can cancel.
good. The last thing you worry about is, does anything cancel on the top and the bottom?
X,
Careful now.
Wait.
The x is canceled.
x,
6 times x divided by x, the x is just canceled.
6 over x
6
minus
over
Yeah.
x minus 2.
The only way 6x could become 5x is if I subtracted x from 6x. Then the coefficients change.
Oh yeah, these x to the 7 down to x to the 6.
Yeah, or if you have powers, then you would subtract them. Yeah, so you gotta be careful. Alright. How are we feeling? I mean, the process didn't care between those 2 problems. It didn't care. Doesn't. So I had a question. This will happen sometimes where you can reduce first. I had an example here somewhere, but I can make one up maybe. Sure, make one up, Jeff. So if you don't notice this, it's not a big deal. It's still going to work out. But there is something to notice. I don't have to give somebody what they're missing. This guy's only got a y plus 1. This guy has more than that. But what happens to this guy? The y's cancel.
Yeah, y cancel.
Yeah, he doesn't really have it. They just cancel out. He didn't really have it. He's just fooling himself. Totally. If it helps you. So I'm going to immediately follow this up with a situation where you wouldn't want to do that.
So canceling something is almost like reducing it down to what the other.
Exactly. It's like lowest form. It's simplified form. It's yeah.
It's like
Bam.
1 over 12, 2 over 24. Almost.
Yeah, exactly. It's exactly the same thing because the 2 and the 24 both have a 2. They cancel. So now I get 5 over y plus 1 minus 7 over y plus 1 is
Minus 2.
negative 2 over y plus 1. Just because the big one's negative. So immediately on the heels of that, here's a problem that looks almost the same as that. And I don't want to make too big of a deal out of this. It's not going to happen to you a lot, but just to make a complete picture, I can cancel these y's out. Can anybody tell me why I don't want to in this case?
Because
Because I'm going to need a y. He's got a y, I'm going to need a y. So somebody kind of, this is like a problem somebody started and then just had to leave. Oh crap, I got to go. And so they already gave this guy a y. So what does he need?
a y plus.
Y plus
Y
1.
plus 1. So you see the difference? I didn't need a y, so I let that one die. I let it go away. I didn't need it. Here, I'm not going to let it die because I need it. If I did kill it, I would give it right back to him.
Yeah, I agree.
Resurrect him. Zombie y, yes.
Why do we have to change the
Change the sign where?
Like, you know, the first problem you gave us, it was subtraction, so you had to make it addition and then move the negative over.
But when it's just pure how many terms is this? 1. Right? So there's nothing to distribute to. It is just -7. So I'll do a problem here in a second. So to finish this one up, he needs a what now again?
Y plus 1.
Y plus 1. How many terms are they going to be here now? It's going to be 2 once I distribute. So then I do have to be careful with the negative. So if you want to, you could do that. And then bring it through. What's up? What's the matter? What's wrong with it?
So you only have to do that. You only have to do that when you have 2 terms on top.
All right, you ready? We're going to finish this one in a second. But I like your question, and it's very important. What you got, Jeff? I don't know, man. All right. So, I mean, I could do that all day long. This will still work, but did I really have to do that? It's either way I look at it, it's -x. But, is that cool? Is that cool? But if I do this, now I have to be careful. Now I want to do that, which I can do any damn time I want to, but here doing that helps me remember to bring the negative to both terms. So in a sense, what you said is correct. I just want to make sure you're looking at it for the right reason. Yeah. When there is just one term, a number or a letter, there's nothing to distribute to. So you're just going to write minus blank, whatever it is. Right? I like it, yes.
So, instead of making that a -7 times a -y minus 1.
Oh, how many negatives do I have?
1.
If I put a negative there and a negative inside there, I suddenly had 2.
Yeah, you suddenly
I've
have
only
to,
got
because
1.
There's a multiplication
Yeah.
process, so
So if I put that, I can either put the negative on the 7, which is actually a little bit easier, or I can bring the negative in before I brought the 7 in, which will still work. I can bring the negative, make both of these negative, and then bring the 7 in. But isn't this going to accomplish the same thing?
well, if it was a -7 that you were bringing in to the negative, wouldn't that make a difference?
Totally. But again, my first point is this. If you do make this a negative and change those signs, you've applied a negative to this and a negative to this. But you agreed with me a second ago that I only have 1 negative. How can it go here and there? It can't. There's only 1 negative. So it's the same thing as what's 2 times 3 times 4? It is not 6 times 8, right? What's the mistake somebody made there?
Negative.
They put a 2 with a 3, and somehow they got another 2 to go with the 4, right? So if I had 3 times 4 and I put a negative in front of it, this is not -3 times -4, right? There's only 1 negative.
Oh, yeah.
Okay, good.
The negative is targeting the same
We know better than that. We know if I have 5 minus 7, that 7 is positive, and I'm subtracting it from 5. It's the same thing as that 7 is negative, and I'm adding it to 5. Those are the same thing. Math says there you go. In fact, math, just to blow your mind a little more than normal, I can't remember if I said this already, subtraction does not exist.
It's always plus.
It's adding a negative. That's not, there's only addition. Division doesn't exist. You multiply by the reciprocal. There's no such thing as division. There's no such thing as subtraction. It's adding the negative or multiplying by the reciprocal. But can we look at it as if there's subtraction and division? Sure, totally. There's nothing wrong with looking at it that way because it works out the same way. I don't know if that really helps, but that's the truth. That's just the reality of it. I don't know how else to tell you the reality. All right. So, let's finish this. Yeah, let's finish this problem. So over here, if I bring that negative up there, what do I get on the top now? 5y.
minus 7y minus
And then just put your like terms together. So negative 2y minus 7. Yeah. Whew. Okay. All right. So that's a little side note. It's not going to happen to us a lot, but if something does want to cancel it if you don't need it. Keep it if you do. That's a simple, yeah. Yes?
For that negative 2y minus 7. Oh wait, never mind. That makes sense.
Cool. All right. All right. So here's the next kind of thing. All right, here's the next wave of attacking algebra. So now that we understand how to multiply, divide, add, subtract rational expressions, the next logical thing is to talk about equations that have them in it and solving them. So, for example, we've done this already a little bit. We've done them when there was just numbers on the bottom. So if I had x over 3 minus 2 over 5 equals 4x over 15. We've done this kind of problem before. I don't know if you guys remember how I told you it was a good way to look at it. I was trying to get you ready for what we're about to do with variables. Who remembers what I said was a good thing to do first?
Isn't that 3x?
What's up? Sorry. So there's no like terms right now, right? No like terms anywhere?
15, that's 6.
3.
What's happening? What do you mean 3? What's 3?
No, I could just say
Are you guys trying to figure it out in your head? That's admirable, but stop. Algebra's going to help me out. It's not going to be, I don't know, maybe I made the answer nice. I have no idea what the answer is.
We divide all the fractions by 15. Not divide,
Make everything LCD.
multiply.
When you have fractions and you're adding, subtracting, what do you want? You want LCD. So what does he need?
3.
5.
5.
3.
3.
Nothing.
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 So I get 5x over 15 minus 6 over 15. And I am allowed to add and subtract anything from both sides. I'm allowed to multiply and divide anything except 0 to both sides. So what's a really smart number to multiply both sides by?
15.
15, because everything's being divided by 15. Screw that 15, let's kill it. That stupid 15 is making all my fractions. So if I multiply everything by 15, if I multiply this side by 15, wouldn't I distribute it?
Yeah.
So I just write it next to each piece. So what happens? Don't do this, don't multiply that, because the 15...
Cancel.
Cancels. 6.
So I get 5x,
Minus 6 equals 4x.
Minus 6.
no x is there in the middle.
Oh.
I don't know. And then you just got to solve this, right? How do you want to solve it?
X is on one side.
True.
Then divide.
Or more specific.
Minus 5x.
Okay.
Negative 6 equals x. Or negative x.
5 multiplied by negative 1.
6 equals x.
Done. Cool. All right, absorb that. Remember that? We talked about that a while back, and I think at the time I said there are other ways to do this problem, but I am going to show you this way because it's going to help when we get to where we are now. Or should. Any questions about that process? If I make all the bottoms the same, I can immediately multiply both sides by it. Why am I able to kill my fractions here, but not here? I could not kill these fractions. I can't, but I can kill those fractions all day.
Those are not fractional expressions.
No, I can kill expressions.
No.
No.
There's variables.
What allowed me to do this? What allowed me? Yes, it's an equation. It's an equation, so I'm allowed to have two sides that'll balance each other. If I don't have an equation, I can't just change my numbers. I don't like fractions. No. Too bad for you. But if there's an equation, I can do the same thing to both sides, and the equation is still true. So you gotta be real. Once you learn to kill fractions, you can't just, I'm sorry, it's not powerful enough to kill them everywhere. Only if they are inside equations.
But isn't it also true that if you have, for example, in number 3, you have all those, numerators, both those numerators and denominators multiplied by a certain number, you just do the same thing as canceling them all out.
If the problem started off with So what I'm saying is, on this step,
Never mind. I think
on this step, I can't just suddenly multiply by y plus 1. I'm so not allowed to do that. I can't just kill these,
Oh, yeah.
because there's no other side to balance me out. I've totally changed the problem if I do that. Alright, so let's try one of these problems with, oh, yes,
Over here,
sorry,
the
who's talking?
negative x minus x, you took away...
Here?
Yeah, negative 1 at the bottom because you needed to be a positive.
Yeah, I got to solve for x, not negative x. And the thing is, the funny thing about us not writing 1, never writing 1, is it makes it look like it's different. But if there's a 2 there, what would I do? Divide by 2. If there's a 3 there, I divide by 3. If there's a 13 million, I would divide by 13 million. If there's a negative 1, I'm going to divide by negative 1. I know that's a negative 1, I just normally don't write it. It's the same thing. Whatever the number is, if it ain't 1, I'm going to divide by it. And that ain't 1, it's negative 1. Alright, so here's what it's going to look like now. Oh shit. Let's see, it's going to say solve. Let's see. Going to rely on my... Start off with this one, yes. Sure. So, as you write that down, ask yourself, does every